Okay, guys, so we are actually discussing the last few topics in the warming up series. Okay, so in the last session, we have been discussing about the 3D printing. We have seen a project uh, from Jerin. Okay, so we have seen how to model a robot in Fusion 360. Then we have converted that model into STL file, and then we have 3D printed that model. Okay, and also Jerin demonstrated some of his projects. Okay, some of his project. I will put that links in the notes. Okay, so that project is completely done using 3D printing. Okay, so this week we are planning to discuss another project. Okay, so which is actually created by Rajesh, who is actually a teaching assistant, or like we can say it's a mentor in this course as well. He already created a course in Udemy, so which is actually talking about this project. Okay, so what I'm planning is today we can discuss about his project, and then tomorrow we can see the simulators. Okay, so that will be the last topic in the warming up series. Okay, so going back to the project, so this is the Udemy link. Okay, you can able to see. Basically, the intention of this session is like how he actually conceived this project. Okay, from the design, how he modeled the robot, then how he 3D printed it, and then what are the functionalities that this robot is doing, and so a lot of stuff he actually mentioned. Maybe we can able to see the different features of this robot. Okay, so we can have a discussion with Rajesh. So he's available for the discussion. So it will be similar to what we have done for the Jerin's project. I will be asking questions to Rajesh. Also, I will be like explaining things, and then you can also ask questions. Okay, so we are expecting to create projects like this. You guys can like learn from this kind of project, and we can do this kind of project after learning the fundamentals of ROS. Okay, so these all are some basic project, I will say. Okay, we can do better than this, but I'm just giving some thread to create projects from these kind of existing works. Okay, so these are some reference that you can take for creating your own project. Okay, so Rajesh, can you able to hear me? Maybe you can. Yeah, can you able to hear me? Yes, right. Okay. Okay, so can you able to share your screen first to show the robot model, or the model that you have created, if you can. Okay, I think Rajesh is having some issues. Okay, okay, yes. So maybe you can watch my live session. Maybe I can just stream to Rajesh. Okay, yes. So, or you can watch the stream from Rajesh. Doesn't matter. I'm just putting this for recording purpose. Okay. So, Rajesh, maybe can you just explain how what is the motivation to create this project? Can you able to explain like why you created this project? Can you? Yeah, go on, Raj. Yeah, I can hear you, but there is some break. Yeah, you can tell me. Okay. 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 So okay, so I think he actually created this project as a hobby when he got some spare time, and the project is like an autonomous mobile robot, meaning the robot can able to navigate autonomously from A to B, which is actually a common project that we all do when we start learning rows. Okay, so Rajesh also I mean prototype a autonomous robot, so that like the intention is like when you give a goal position to the robot will be autonomously go to that position. I think in the last project also you have seen Jerin's project, right? Which is also an autonomous mobile robot. So I just included this because you will get an idea how to create, how to prototype an autonomous mobile robot from your own. Okay. So Rajesh, can you play this video? I mean, what is this video for? Okay. 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 Sure. 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 Yeah, so this is the actual model, I mean, the hardware. You can able to see there is a two-wheel robots, and there is a supporting caster wheel. And from the first look itself, you can find this is actually 3D printed. The yellow color, everything is actually 3D printed, and there is a screen on the center, LCD screen, which is like giving for like the status, or I mean what the robot is actually doing now. It's just printing that status, and there is an LED as well. So maybe Rajesh, you can explain the functions of the LCD and LED. Maybe you can just explain. Okay. Yeah. Okay. Okay. Yeah. Okay. 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 Yeah. Okay. 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 Great, great. So from the robot itself, we can just read out the status and also the main signals, like whether it can't able to navigate, or if there is an error, or if the goal is actually executing. So this is a good way. I mean, when you if you remember Jerin's project, there was a battery indicator as well. I'm not sure Rajesh put a battery indicator in this robot. Is there any battery indicator, Rajesh? Okay, okay. So you can. Okay, okay. So all the functionalities, I mean the basic things are there in front. So you can just read out everything from the screen, LED, and the battery indicator. Yeah, just go on, Rajesh. So now I think it's awaiting for the gold, right? Okay, 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 and it's ready. Okay, okay, mm-hmm. Okay, 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 okay. Got it. So you have loaded with some, I mean, predefined goals, or okay, 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 okay. So okay. So, guys, I think Rajesh actually mapped his whole house, and then he actually um, uh, selected some goal position that the robot has to go. So we can actually move the robot to that goal position from the button press. You don't need to like work with rows or play with the Ubuntu or something like that. Yeah, everything can be done from the robot itself. Like when one button press, it will go to the goal one. And if the button, like for example, imagine a scenario like the robot has to carry a food from kitchen to your dining room. So um, like the person can press the kitchen goal position, then the robot will go to the kitchen, then after putting the food, then select the another goal position, then it will go to the dining. So it seems like interesting, Rajesh. Yeah, go on, you can play the video. Yeah, so now I think it's selected a goal. Now it's moving to the goal position. So this is his house. So the robot is actually moving, and on the top you can able to find the mapped area of his entire house. The robot is actually now in the kitchen, right? Okay, okay, great. So when it reached goal, the you can see the green LED is actually turned on. Okay, great. Now we are giving another goal, right, Rajesh? Okay. Okay, yeah, so we already given, so you can find the robot got another goal, and it's going to that position. So it seems like to, okay, to the home position. Okay, 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 that's great. Okay, okay, so this is the use case, guys. Like it's a indoor robot, wheeled differential drive robot, which is having two wheels and the caster wheels, and the robot can take commands from the user by a key press. It can store multiple goal position. So based on the goal position, it will go to that position, and yeah, so user can able to like select the goal position from the key press. That's an interesting thing. So this is what the robot doing, and now we can check from the beginning, like how he conceived this project. So Rajesh, I have a question. Like, how you started designing this robot? Do you have a some reference model, or you have designed it from scratch? Okay, 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 yeah, okay, 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 great. Okay. Yeah, aesthetic side of the robot, right? Aesthetic. Okay, okay, that's cool. Okay, 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 okay. Interesting. Okay, okay. So from the scratch. Okay. So from where did you buy these motors? All these components. Did you created a 3D model of the robot, or how you started with the project? Okay, 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 Okay. Okay, so you didn't design the complete robot model, or oh, okay, 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 great. So you actually created individual parts in 3D, right? Okay, and you didn't assemble it. You didn't assemble it. Did you? Did you? Okay, okay, great, great. Okay, okay. Okay, yeah. So that's a kind of assembly, and this assembly is actually for the 3D printing or the prototyping. Okay, okay, okay. So, yeah. Okay, okay, okay. For the simulation. Okay. Yeah, 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 yeah. Okay, so I think the Jarin is also done the almost the same thing. Like he actually modeled in the Fusion 360, and then he actually printed the individual parts using 3D printing. You actually use the Tinkercad, and then you designed everything. I mean, then assembled it together, and then yeah. So this is a complete robot model, right? With in individual parts. Okay, okay, great, great. And then you actually converted these model into STL. Is that you did, or for 3D printing? Okay. STL. So this Autodesk Tinkercad, is it free to use, or okay, 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 okay. Oh, is it easy to use as well? Okay, okay. So, guys, I think this is actually a new thing for us for 3D modeling. One of the easiest method is Tinkercad. So, if the robot is not much complex, I think this model also, like, I mean, the inner parts are quite, I mean, looks complex, but I think we can prototype it easily using the Tinkercad. Okay, yeah, that's a new information. Okay, and then after modeling, you started the 3D printing, right? Okay, okay, okay. So, okay, so which is the 3D printer that you are using? Okay. Yeah, I think Rohan made a comment. Yeah, yeah, Tinkercad. Yeah. So, I think you guys can use any CAD software. It's all about like creating the model. So, yes. Okay. Ender V2. Okay, okay, okay. Okay. And did you buy a new one, or it's a already used one or something? You bought it a new one? Okay. Yes, yes. Yeah, 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 yeah. Okay, Rajesh, just a second. It's raining outside. Let me close my window. Just a second, guys. Yeah, we can start. Okay. So using that you have 3D printed, and then how was the assembly? Like, was it easy, or like, um, I mean, after 3D printing, how you assembled it? Okay. Screw, right? Yeah, yeah. Yeah, yeah, Rajesh. Rohan is having a question. The 3D printer is Ender 3 V2, right? Okay, okay, okay. Yes, yes, Rohan. Okay, okay. So you have assembled it. Then is there any metallic part, or completely? I mean, 3D printer. Great, great. Okay, okay, okay. And how much time it took to 3D print all the part? Okay, okay, okay. Oh, yeah, yeah, yeah. Okay. Yeah, PLA is the material. PLA problem. Okay, okay. Yeah, yeah. And are you continuously printing, or and is there any I mean difficulty like such as like power failure? Due to power failure, you I mean lost the part or something. Can you share some experience like the 3D printing experience? Okay. Hmm. Okay. Yeah. Yeah. That's a common issue. Also, Jaren mentioned that issue. Yeah. Yeah, I'm just switching into another topic. Like, after modeling the robot parts, so did you started the simulation first, or you started 3D printing it first? What was your approach? Yeah. Okay. Okay. Printing. Okay. Okay. So after designing, modeling, you started simulation, right? So do you have any videos of the simulation you have done? Okay. Okay. It's in the code. Okay, okay. So teleoperated. Okay, okay. Yeah. So this is actually showing the gazebo sim. So this is a simulation, guys. Like on the right side, we can see a simulator called gazebo, which is actually coming along with rows. Gazebo can work as independently. Also, we can integrate to rows so that we can communicate to gazebo through rows. Okay. So gazebo rows integration is very good now. So we can like uh, simulate a robot in gazebo and take out the sensor value to rows for processing. Okay, so you don't need to worry about the rows stuff or something. Just understand that there is a simulator called gazebo and we can work with rows. That's it. Okay, so in the left side you can see a map of the simulated environment. Okay, and the position of the robot is also there. So can you just okay, so here he actually created a simulation, and also he created the navigation software, right? Navigation stack, you can see we can give a goal position on the map, and then the robot will be moving. Yeah. So there is a question from Rohan. Let me check. uh, Heating issue. Okay, okay, okay. I will get back to that, Rohan, after this. Yeah, you can just play Rajesh the video. Okay, so you guys can see the robot is autonomously going to that goal position. Okay, but this is happening on the simulation. Okay, so after 3D modeling the robot, we are implementing the simulation, so that will give you a confidence that your design will work in the simulation. Simulation is like an ideal environment. But in reality, if we conceptualize the actual hardware, there will be some issues like the noise and all from the sensor will be there. But after simulation, you will get an idea whether your design will work or not. Okay, and also we are creating the software using ROS, so this software can be used in the hardware with some fine tuning as well. Okay, so this is a simulation environment that he created in Gazebo, and he actually used the ROS navigation stack, which will be we will be discussing that on the ROS 1 module. Okay, yes. So after simulation, after doing the basic navigation or teleoperation, you started the 3D printing, right, Rajesh? Okay, okay. Can I see the 3D printing images, like fully assembled one? Just want to. Okay, this one. Okay, okay. Okay, okay. So there is a question from Rohan. Like after the robot is actually not very big, right? There. So yeah, and is there any heating issues? Like it seems like you are using Odroid. Are you using Odroid? Okay, sure, sure, sure. Oh, okay, okay. It's not too small. Yeah, it's yeah, okay, okay, okay. Okay, okay. Yeah, it is having a yeah good amount of height. Yeah, yeah. Good, good, great. Yes, yes. Yeah. You can just stop sharing. Yeah. You can start sharing the screen. So yeah, the robot, it's not too small, and the heating issue, I think, Rohan, the the main component that will have the heating issue will be the PC, the computer. So seems like there is a heat sink plus a fan. So which is the single board computer you are using? Is it order? XU4. Okay, okay. So guys, there is a board, single board computer like Raspberry Pi. It's called Odroid. If you just Google about Odroid, you will get. I also have one Odroid, Odroid C2 or something. I have one board in front of me. It's Odroid C. Yeah, Odroid C or something. It's very similar to Raspberry Pi, but it is more. It is having more specs compared to. But currently, Raspberry Pi latest model is having much more performance. But Odroid XU4 is actually like, at that time, before 1 year, I think it's actually very good because the form factor, the size of the board is not very big, and it is having a fan, so the heating issue will not be there, and it is also having a good processor, so we can run, processor intensive navigation, anything on that. Okay, yes. And yeah, so now I just want to know how you selected the components after the simulation. How you selected the components? So that is next question, Rajesh. Can you just explain how you what are the criteria that you have in mind, had in mind actually, while selecting the motors, then PC, then lidars, then battery? Can you just explain about it? Yep. Okay. 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 But it's actually expensive, right? How much it was? 6,000. Okay. Okay. Yeah. Okay. Sure. Sure. Okay. So So LiDAR, and in which website you purchased? Do you remember? Maybe an Indian site, but you will be avail. I mean, that will be available in other countries as well. Okay, okay, okay. Yeah, I think it will be available in most of the online. Yeah. Okay, okay. Got it, got it. And what about the motors? Where did you buy the motors? Okay. I think it's from Robo.in or RoboKits India. Okay, 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 okay. And also it is having the encoder, right? Yeah, so the encoder is actually giving the feedback of the movement. Yeah, we will discuss that while discussing rows. Okay, okay. Yeah, and yeah, so and why you choose Odroid XU4? Is there any specific reason for that? Okay, okay. Yeah, yeah, yeah. Yeah. Ubuntu Mate, right? Ubuntu Mate. Yeah, yeah. Okay. Yeah. Yeah, so guys, I think so when you work with the single board computer, especially Raspberry Pi, so Raspberry Pi is actually very popular, and there are different board revisions. Actually, Raspberry Pi 2, 3, 4. Currently, it's 4. So before 1 year, the Raspberry Pi is actually coming up with its own operating system called Raspbian. Okay, it was not Raspbian at that time. It's like I mean Raspberry Pi OS. Okay, it was Linux. It was based on Debian, but Ubuntu was not properly supported. Okay, now in Raspberry Pi 3 and 4, now Ubuntu Mate will support. Okay, but in Android, from the basic model, it was supporting Ubuntu. Okay, so Ubuntu ARM version, which is ARM based processor version, so you can easily install ROS into it. And I mean, we are working with Ubuntu on desktop, so if we get Ubuntu on the Android or the single board computer, then it's very easy to work with, right? So that's why Rajesh choose the Android XE4. So but now if you want to work with Ubuntu, then Raspberry Pi is there. Then if you can go with Android, then you can select Android. But I will prefer Raspberry Pi with a heatsink and fan. Okay, the advantage of XV4 is that it is having a heatsink with a fan, which is very important while working with autonomous robots. Okay, because in Jerin's project, you have seen the Jetson Nano. Jetson Nano is having a heatsink, default heatsink, but I think Jerin put a fan on the top, which is very important. Okay, because while we do navigation, localization, it is taking a lot of CPU. Okay, so it will heat up, and in order to avoid the heating problem inside the robot, it will be better to put an additional fan if there is no fan. But if you can buy this kind of modules, I mean the single board computer with a fan, that will be great. So if you check Raspberry Pi, you can buy the heatsink with fan modules. So maybe you can think about that. Okay. Okay, so then after that, so we have discussed the Odroid, and do you remember the cost of Odroid at that time, Rajesh? 4,000. Okay, okay, okay. Now maybe the price may be dropped, and maybe new versions will be there. And is there any other components, like there will be some microcontroller board, right, for working with the motors or something? Is there a okay? Yeah. Okay. I mean, like, is there any motor control circuitry? The circuit that is okay. 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 Oh, so so did you buy this or you created by your own? Okay. And controlling from the Android. Okay. Okay. Okay, okay. So it seems like in this robot, Rajesh is not using any microcontroller board. So if we are using yeah, right. Okay, okay, got it, got it. So initially, when you start working on the robot, you thought like you can control the motors from the Android, and we can able to do it. But if you want to, I mean, control some other devices like the motor controller or LCD or push buttons, then it will be better to add another microcontroller board, okay, like Arduino or TNC or Tivasi Launchpad. I mean, there are many microcontroller board. Popular one is the Arduino. So if we can use that, and if we can connect the Arduino board to the Android or Raspberry Pi through USB, then the microcontroller board can handle the motor driver, encoder, then IMU if there is any, or LED or any other things, okay, that we can easily interface. And the Android or the computer of the robot is having Ubuntu, ROS, then all the navigation. Okay, so that is one approach that we can do. But if you are working with Raspberry Pi, maybe we can make use of Raspberry Pi GPIO pins. Okay, but I mean, both ways are okay. But most commonly, we will use the Arduino for communicating to these kind of thing. Okay, yes. So other than the motor controller or droid motors, there is battery, right? Battery. So how much battery is there? How much? How many? How many battery? Okay. Okay, yeah. So I think there are two battery, or like I found one on the bottom, and is there what is on the right side? Oh, it's a battery indicator, right? Okay, okay, okay. That's okay. So there is only one battery pack, right? Okay, and what is the voltage? Is the 22 point, okay, 22.2. And then you have to use this battery for powering the XU4, then motors, then everything, right? Okay, okay. So yeah, okay, 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 okay. You use buck converter or okay. Okay, 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 okay. So I think Trushant is having a question. Let me know. The initial Raspbian was 32-bit limitation. Okay, one issue was using SPC. Okay, Trushant, I think not only the a 32-bit thing. We can still install ROS on it. We can like I mean build ROS from the source code in the old Raspberry Pi. But the thing is that no, it's not about the architecture or the 32-bit or 64-bit. It was more like I mean we are very used to Ubuntu, but the Raspberry Pi OS was like I mean it is actually based on Debian, and the desktop environment was again a new one. So we will not be very comfortable with working with that. So so when we want to choose a board which is having Ubuntu and a new operating system, we will obviously go with Ubuntu, right? So that was one motivation. Even I had the same feeling when I work with Odroid. I use Odroid in some projects because of this factor. And also in older boards which is having Ubuntu, the apt install was not there for ROS. Okay, the ARM architecture was not supported. It was actually started when the Turtleboard 3 released, because Turtleboard 3 actually used Raspberry Pi, and the Turtleboard 3 guys, that company Robotis actually created the ARM based ROS support, so we can install ROS on any ARM based board. Okay, so if you have an Ubuntu ARM based PC, then we can install ROS. So in both ways, I mean the main thing was like user experience. Like if you work with Ubuntu, I think it will be much easier than working with this. And also the packages, all the Ubuntu packages are available in Odroid, so we will not feel difference. I mean we will not feel any difference if we work with desktop and Odroid. Yeah. So okay, so come to the project. So so in the battery there is a port for charging and port for I mean taking the output, right, on the battery. Okay. And there is a battery indicator that is on the right side, right? Okay. Okay. So you bought a battery indicator module. And then how that battery indicator module works, is it directly connected to the battery and it will work, or do you want do we want to interface to Arduino or something? Battery. Okay, so then it will display. Okay. Got it. Okay, I think these are the important parts, and you guys can see the 3D printed, and it's not easy. So even when you start working on some 3D printed projects, robot projects, just understand that it's not an easy game. It will take time. It need a lot of patience and also money. Like you have to buy, or you have to outsource the 3D printing to some vendors, or you have to buy a cheaper version of 3D printer like Ender or something like that. So that is about the robot parts, then 3D printing. Now we can come to the software side of it. Okay, so in the software side, Rajesh, can you able to see the architecture of the software? How you created this autonomous navigation robot? So what is the architecture? I think in some videos, I think you have discussed the architecture. Okay. Yes. So this is the architecture, right? The software architecture. So you guys can see, like on the bottom, we can start from the bottom side, bottom of the picture. Like there is a left motor and right motor, and in order to control this motor, we have the motor control circuitry, and these control circuitry is controlling by the PC, right? like the central planner. Is the central planner is it's actually, yeah. Okay, got it. So yeah, Urvashi is having a question. Yeah, it's a differential drive. There is two wheel, and you can see left motor and right motor, and in each motor there will be encoders. Encoders are actually sensors that is attached to either wheel shaft or the tip of the motor. Back of the motor, and when the robot rotate, the encoder will also get some ticks, okay, based on the motor movement, and from that motor movement we can compute how much distance the motor travels, or how much distance the robot traveled. Okay, so it's actually it's a very important sensor for getting the robot position, the local position of the robot. And so the robot, the speed commands are coming from the central planner, which is actually running on the PC. Okay, on the Odroid there is a program running called MoveBase. We will see that in the ROS course. So the MoveBase is the program that is running on Odroid, which is sending the velocity commands to the motors. Okay, so the velocity commands is like linear and angular velocity. So linear means moving, if we give a linear command, linear velocity, the robot will move forward, move backward, like that. If we give a angular velocity, the robot will rotate. Okay, so if you give a combination of linear and angular velocity, the robot will be like moving a circle, or like, you know, right? So that kind of velocity commands is coming from the central planner, which is actually a program called MoveBase, and that program can able to handle multiple things. For example, in an autonomous mobile robot, this node or program called MoveBase is the main part of that. Okay, so the MoveBase is connected to the sensor. The MoveBase is having the map of the environment. The MoveBase is having the current position of the robot. Okay, so all these things are coming to this MoveBase. Okay, then the MoveBase is giving, for example, if you are giving a goal position, it is actually going to this central planner or central node called MoveBase, and the MoveBase is giving the appropriate velocity commands to the robot in order to reach that goal position. Okay, so this is one of the main part of our ROS 1 course called navigation. Okay, ROS navigation. So from this example you may get an idea the importance of the ROS navigation. So in the ROS navigation, if we, the important program is called the MoveBase. Okay, there is only one program in ROS navigation which is called the MoveBase. That is actually showing us the central planner. Okay, so the MoveBase is handling the autonomous navigation of the robot. Okay, so this is one. And do you have any other architecture diagram, Rajesh? Circuit or something? Okay. Okay. Okay, so here is the wiring diagram. Let me see. Yeah, so this is the detailed wiring diagram. So in order to make a robot, I already mentioned you should need a basic understanding of electronics. That's why we included the fundamentals of electronics, embedded all these things in the warming up series. Okay, so you guys can see like these are the components in the robot. Okay, you guys can see the Odroid XU4 is a brain of the robot, and the Odroid is connected to an Arduino Mega, okay, which is a microcontroller board, and the Arduino Mega is interfaced to like buzzer, push button, LCD, status LED, all those stuff. Okay, then Odroid is actually a computer, and the Odroid is connected to the USB hub. Okay, and through the USB hub it is connected to the LiDAR. Okay, LiDAR is also we can connect through the USB. Then the motor controller, which can also connect to the USB. Then the Wi-Fi. Okay, so the communication from the robot to the laptop, or if you want to communicate to the robot from your computer, maybe from laptop, there is a Wi-Fi adapter. Okay, so you can connect to this. So Rajesh, is it a hotspot or is it just a dongle? Yeah, so this Wi-Fi dongle will be connected to our network, maybe a router, and then we can just access to this robot or to the computer or Android PC through SSH and all. Just ignore it. Like, just understand, we can access to the robot computer from our laptop. Okay. So and also there is a joystick dongle that is connected to the XU4. Okay, and you can see here, this is a battery section, and there is a battery monitor that is directly connected to the battery, and there is some step down circuit which is actually like for the motor, for working with the motor we need 12 volt. Okay, but in order to work with RP LiDAR and Odroid, we need the 5 volt. So the battery is 22 volt. Okay, so basically we have to step down the 22 volt to 12 and 5 volt rail. Okay, so that we can take the 12 volt to motor driver and 5 volt to Odroid. Okay, so this is a circuit. So you should require some basic understanding of electronic circuits, then only you will understand this. Okay, but maybe we can have a discussion maybe later when we work with rows and all. Okay, so this is the thing, and so we have seen the circuit, we have seen the architecture, and okay, so do you have any other things to show, Rajesh, other than this? Like, if I miss anything, can you just yeah. So these all are the part of ROS actually. So in order to autonomously navigate, initially you have to build a map. Okay, so this is how we can create a map, and there are some existing programs available in ROS to create a map and all. And the important part of this project is the navigation tuning. Meaning, I mentioned that there is a program called MoveBase, which is the heart of navigation stack in ROS. So using navigation stack, we can able to create autonomous mobile robot. And it's not easy to work with the navigation stack because there are hundreds of parameters in the stack. Okay, in this program. So we have to fine tune this, then only the robot will move smoothly. Okay, so those things are on the ROS side, and this is how the robot works. I mean the working of the robot. When we start the robot, it will be waiting for the goal position. Okay, so the goal position is basically getting from the button press. Rajesh already mentioned that if we press the button twice, it will go to the goal 2, and based on the number of ticks, it will go to the appropriate goal. So I think if there is a okay, so after pressing the button, it will be selecting the goal and move towards the goal. So Rajesh, I think I have a suggestion. If you have an option to select the goal and then press OK or something to start start moving to the goal, is there any option for that now, or it will directly go to the goal position? Yeah. Yeah. Okay, so you don't. Y- yeah, I mean, it can happen, but the thing is that if you have two push button, then it's like one push button is for selecting the goal number. So if you keep on pressing that button, you can select the goal number, if it is goal 2 or goal 3. Then if we press an OK button, then it will be processed like that. So yeah, so it's a small suggestion, that's it. Yeah, so I think we have explained, I mean, we have gone through most of the stuff. Maybe if you have any more video, yeah, these kind of demos, maybe we can see. Yeah, so the LiDAR is on the top. So the LiDAR is actually the sensor which is helping us for mapping the environment and also to navigate. And yeah, it's actually a 360-degree LiDAR, meaning we will get the 360-degree view. The LiDAR is actually coming up with the obstacle around the robot. Okay, so from that obstacle we are like I mean, taking decision. We can map, we can navigate all this stuff. Okay, so it is a rotating LiDAR, and in each rotation it will be getting back with the obstacle around the robot. And yeah, currently it's putting on the top of the robot, but there are some limitation in this model because it can only detect the obstacle in that plane. It's a 2D LiDAR, meaning it can only get back with the obstacle in that plane. Okay, but if the obstacle is actually I mean, the height is lower than the height of the LiDAR, it may not detect, right, Rajesh? So it's actually like a, I mean, it's a hobby project, so there are limitation. But if we can put some 3D depth sensor, maybe we can handle it. Yeah. Yes. Maybe can you play the video? Yeah. Yeah. It's again. I think it's the same. Yeah. Let me see. Okay. So again, I was getting a lot of, I mean, what suggestion from my mother, like creating a robot for, I mean, helping me in my kitchen, like maybe for, I mean. Delivering the food or something like that. But this is a robot like that, like it can go to some position and maybe it can collect food and get back to the initial position. Yeah, so using this concept, using the autonomous mobile robots concept, we can, I mean, implement many functionalities, many applications. Okay, so yes. Okay. Yeah, it seems like the movement is also very smooth. It's working very good. But again, it is having some limitation. I hope I can give Rajesh can also give some access to this course. Maybe while we discuss the autonomous mobile robot concept in ROSE, so you will get a reference. I mean, you will get a reference project. Okay, guys, I think now it's a time for concluding the session. So now you can do, I mean, you can have a Q&A session with Rajesh. If you have any question, maybe I can also, Rajesh can answer for your questions. Okay, so let me know if you have any question regarding this project. Any question, guys? Maybe you can just unmute your mic and ask. That will be the better way. Any questions? Yeah, Rohan is commenting. Yeah, good work. Yeah, it's a nice project. Yep. Maybe Rajesh, you can stop the streaming. Okay, okay. Any question? Anyone? It's all clear, right? Yeah, yeah. Yeah, it's a good question, Rajesh. Do you have any I mean suggestion? Okay, 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 okay. Yeah, so okay, so I will get back to the question from Kalpesh. Just a second. I just want to complete Tushant question. I mean answer. The thing is that so he also want to know like while 3D printing, what are the things that we have to avoid? I mean, is there any suggestion while because those kind of stuff are taking a lot of time, right? So do you have anything to say like what are the things that we have to avoid while doing 3D printing? Any kind of suggestion? Okay, 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 okay. Yeah, yeah, yeah. I think yeah, yeah. Yes, there are some issues with this. Yeah. Yes. Okay. Then so after buying the components, do you have any I mean experience like whether the components is bad or did you return any component that is not suitable for the application, something like that? Okay. 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 Yeah. Okay. 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 And for the battery, you have to buy the battery charger as well, right? So that is also costly. Okay. 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 Yeah, yeah, yeah. We can mention that in the notes. Okay. And Kalpesh is having a question. Is it possible to elaborate on type of wheel? So where did you purchase the wheel and what type of wheel it is? Okay. 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 It's just a compatible wheel, right? And it seems like it is having a grip, like it is having some dots, so that there will not be much slip. Yeah, It's a rubbery kind of material, right? Rubber. It's a rubber material. Okay. So like that is again an important one, because if you are going with a plastic wheels, then there will be a chance of slippage. So the problem is when the wheel slips, then we have the encoder inside it, right? So based on the encoder, we are calculating the robot position. So if the robot slips, if the wheels of the robot slips, then the position estimate of the robot will have error. Okay, so this kind of wheels are good only. Even it is compatible with the motor. One of the advantage is, I mean, what I'm seeing is it is made of rubber, and also it is having some grip. So the possibility of slippage is actually very less. So the odometry or the position estimate of the robot will be like mostly accurate. Okay, yes, so that's it, guys. I think if you have any more question, you can post it in the RDLP discussion channel. Rajesh is also with us, like he will answer. And if you have any direct question, you can directly send to Rajesh, okay, or Jarin. Yes, so that's it for today. So tomorrow I'm planning to discuss different kind of robot simulator. It's again an introduction. I just want to discuss Gazebo, webboards, and VRAP. Okay, it's very introductory session. Okay, and after that, after this, we are concluding with the warming up series and starting with rows. Okay, yes. Okay, okay then. Thanks for attending today's session. See you tomorrow. Okay, have a nice day. Bye. Good night.